This video is for integrated 2MA, and this is for the chapter 4.5 to 4.8 D-Day. Now, in this first section, we're going to be dealing with arc cosine, arc sine, arc tangent. And what you want to remember is arc cosine is the same as cosine inverse. And that really means we're trying to find an angle that gives us a particular cosine value. And we're also going to be talking about arc sine, which is what angle gives us a particular sine value. And again, that's also sine inverse. And similar with our arctangent, that is the same as tan inverse. And this is, again, what angle gives us particular tangent value. Now, for each of these three, we're going to be looking at two particular quadrants for each of these to find those angles. So when I'm dealing with letter A, which is dealing with arc sine or sine inverse, same idea. Sine, remember, is your y coordinate on your unit circle. So that's positive, positive above the x-axis, negative, negative. Now, when we're focused on our sine inverse or our arc sine, we want one negative and positive quadrant that are next to each other, and we go from negative pi halves to positive pi halves, okay? Now, in these two quadrants, I'm going to be looking to see where is my sine a 1/2. And this point right here corresponds to root 3/2, comma 1/2. So my sine is equal to 1/2 at that spot. And that spot is pi 6. And that's my answer. On B, cosine inverse. So when we're thinking about cosine, remember cosine is your x coordinate, and your x's are positive in these two quadrants and negative in these two quadrants. Okay, it's positive on the right side of the y-axis and negative on the left side of the y-axis. So in this case, when I'm focusing on the two quadrants, I'm going to focus again from here to here this time, because that's where I have a positive and negative next to each other. So I'm going to be looking from 0 to pi. This is the spot I'm going to be looking. And I want to see, where is my cosine a negative root 3/2. Basically, where is my x coordinate a negative root 3/2? And that's going to be here, because that point corresponds to negative root 3/2, comma 1/2. And the angle there, the radian there, is equal to 5 pi 6. So that is my answer. Now, before I talk about the arctan, I'm going to remind us of a video that I showed us where we use our hands to represent all 5 fingers, each of the 5 values in, let's say, quadrant 1, for example, and how you can use that to help you with tangent. So let me get that video up for us.
For tan, we still count fingers, but there is just one extra little twist. The same as for sine and cos, bend down the angle finger. So let's find tan 60.
And that would be
Let's
pi
down our
thirds.
finger. We've got 1 cosine finger above and 3 sine fingers below. For tan, we flip our hand over and we have 3 sine fingers above and the 1 cosine below. So tan is square root fingers over square root fingers. So square root 3 over square root 1, which simplifies to root 3.
And again, that is for tangent of pi thirds.
What would tan 30 be?
This would be tangent of pi 6.
Work out the answer and click here when you're ready to check.
So you see that there's 1 finger above and 3 fingers below.
Which would simplify to 1 over root 3.
And we would rationalize this times top and bottom. We would do top and bottom. So here I have 2 situations I'm showing us that were in that little video clip. So here you see this would be 1/2 for your cosine. This would be root 3/2 for your sine. Now that is x. This is y. tangent is sine over cosine, or y over x. So we flip the hand over, and you see you have root 3 over root 1, which ends up being a root 3. Now that, when it says 60 degrees, is pi thirds, okay? Now, when we have 30 degrees, which is pi 6, we have root 3 halves above, okay? And for our cosine, our sine, we have root 1 or 1/2 below. Okay, so that's root 3 halves comma 1/2. Again, this is our x or our cosine. This is our y or our sine. But when we flip our hand over, we're going to get a 1, okay, and a root 3. So that's 1 over root 3, which we rationalize to a root 3 over 3. So a lot of times I will use my fingers and just pay attention to when I flip it, if it's a 1 over root 3, which is going to clean up to this, or just a plain root 3 over 1, which cleans up to that. Okay, so that's how I'm going to sometimes refer to it, but I will also show us how to do it just using the coordinates. Okay, so in this particular problem here, we want a negative root 3 over 3. So I am looking at this situation here where I'm at the 30 degrees or pi 6. Okay, now let me just get these off of our screen here. Now, when I am focusing on tangent, okay, tangent is positive in these two quadrants because the x and the y coordinates are either both positives or both negatives. Okay, and again, tangent is sine over cosine or y over x. You can think of it as slope, rise over run. And it's negative in these two quadrants because in these two quadrants, my x and my y are different signs. So when I do that division, I'm going to get a negative. Now, we also need to remember that our tangent has a denominator, and that denominator is my cosine. And so I want to think, well, where is my cosine 0 or my x 0? Because that's going to make it undefined. And that's going to be up here at 0, 1 and down here at 0, -1. So we have asymptotes there. So when I'm trying to figure out the two quadrants that I'm going to do for tan inverse, you see I've got positives and negatives next to each other in different spots, where over here going this way was positive, positive, and that's not what I wanted. Okay, I wanted to get a positive and a negative. Over here, this is positive, positive, so the one that worked for my sine doesn't work for my cosine. Now, over here for my arctan, this one, when I'm doing this, if I go from here to here, I'm going through an asymptote. I don't want to do that. I want to go from asymptote to asymptote. That's how I think about it. So I want to go from here to here. And like my sine inverse, since I'm down here at the bottom, this is not going to be a 3 pi halves. We're going to consider this a negative pi halves to a positive pi halves. So that's where I'm going to be looking. Now, again, I want to have my tangent be a negative, so it's going to be down in the fourth quadrant, and I want it to be a root 3 over 3. So if I look at those values I showed us before, so if we look at these values here, so if we're looking at the pi, this would really be pi 6. You see you have 3 fingers above, so that would be a root 3 halves. You have 1 finger below, so that would be a root 1 or 1/2. Now, when I flip it for tangent, I'm going to have 1 above, I'm going to have 1 below. So that is giving me my 1 over root 3, which I then would rationalize. Okay, a 1 over root 3, top and bottom. So that is going to be the one I want. I want the 30 degrees or where the pi 6 is. So I am going to be here at this point, okay? Sorry, not at that point because it's a negative. I apologize. It is a negative root 3 over 3. So I'm going to be here at this point. Now, again, the coordinates here are a positive root 3 halves, comma, a negative 1 half. Now, if I was to do tangent, which is sine over cosine, I can change this by, when I divide by a fraction, I can multiply by the reciprocal. You see that cancels out. You see I get my 1 over root 3, which is the same thing I got with my fingers. Then I'm going to rationalize it like I did and get a negative root 3 over 3. So that is a spot that I'm at. And that spot is a negative pi 6. That's where that spot is. So this is going to equal a negative pi 6. Okay. Okay, so wanted to kind of spend a little more time explaining these three situations: arc sine, cosine inverse, which is an arc cosine, and arc tan, so that we understand that we're looking in three different situations, three different spots. Okay, so let's move a little faster through these other ones. Okay, so on D, I am going to be looking for my arc sine first. So I'm going to find this angle. So when I'm looking at arc sine, remember, I'm going from here to here. So where is my sine? A negative 1 half. It is here. And that is at a negative pi 6. So really, I now want to find the cotangent of a negative pi 6. So basically, I want the cotangent at the spot. So this spot is a root 3 halves, comma, negative 1 half. So when I'm thinking about cotangent, cotangent is x over y. So that's going to be the root 3 halves over a negative 1 half, which when I clean that up, is going to end up being a negative root 3. You can also do it with your fingers. And when you're doing this, you don't have to flip it because you're going to have x over y originally. So what I mean by that is if I'm looking at this one here, okay, and I'm just thinking about it. Let me get rid of these. And I'm just thinking about it as a the original direction. Again, this is root 3. So root 3 halves, comma 1 half, root 1 half, which is 1 half. Now, I'm just going to take the numbers above, which is my x, and my numbers below, and I get my root 3 over 1. That is what my cosine is. My cotangent is, sorry, at that spot. So my cotangent, my final answer for this question is going to be a negative root 3. That is my final answer. Okay, on E, this time the inside is going to be just a cosine. It's just a cosine. It's not an arc cosine. So I'm going to go to where my angle is a 7 pi 4, which is here. And this point is a root 2 halves, comma, negative root 2 halves. I want the cosine of this. The cosine of this is my x coordinate. So what do we want now? We want the arc sine of root 2 halves. That's what we want. And remember, arc sine, I'm looking from here, whoops, change the color to coordinate. I'm looking from here to here. So where is my sine a root 2 halves? Well, my sine is a root 2 halves here. This is going to be root 2 halves, comma, root 2 halves. But this is where my sine is a root 2 halves. And where is this? This is going to be at pi fourths. So my final answer is pi fourths. That is my final answer. Okay. Answer pi fourths. On letter F, this one has a lot going on here, but so I'm going to do what's inside. Okay, so I'm going to do what's inside this first. Now we notice there's two things inside here. The thing I'm going to focus on first is going to be this. Okay, let's figure out what that is. So remember, cosine inverse is from here to here. So I am going to be focused from here to here. I want where my cosine is a -1/2. My cosine is a -1/2 here. This is a -1/2 comma √3/2. And the value of that is going to be 2 pi thirds. Okay, that is a 2 pi thirds. So what's happening now is I'm going to be taking tangent of, and I'm going to put that 2 pi thirds in here. And then I had this 3 pi halves. That was there. I'm going to clean that up. I'm going to get a common denominator. So I'm going to write each of these in terms of 6. So I'm going to be multiplying the first fraction, top and bottom, by 2. So I'm going to times 2 times the top, 2 times the bottom. And when I do that, I'm going to get 4 pi 6. I'm going to times this one by 3 and by 3. So I'm going to get plus 9 pi 6. So I want to get a common denominator. And then let's clean this up. So this is going to be tangent of 13 pi 6. Okay, so I need to figure out around this unit circle, because it's not an arctan. I'm not focused on 2 quadrants. I'm focused on the whole unit circle. Where is my tangent? What is my tangent at 13 pi 6? So I know that if I went all the way around the unit circle, that would be 2 pi, but it's also going to be 12 pi 6 if you want to think about it that way. And so I'm going to go 1/6 more. That's one way to think about it. Another way is, let's see, how many times does 6 go into 13? It goes twice, which is 12, with 1 left over. So what does that mean? It's 2 and 1/6 pi. Okay, now 2 pi is going to be here. And then I'm going to go 1/6 above that, which is going to be here. And then I want the tangent at that angle. Now the tangent at that angle, okay, the coordinates there, let me write them in here. The coordinates there at my basically pi 6 is √3/2 comma 1/2. So either I'm going to do 1/2 over √3/2 and clean that up. I'm going to also think about doing it using the finger method. So if I'm doing that, which is basically this 30 degrees, I'm looking at this picture here. I had √3/2 comma 1/2. When I flip it, it's 1 over √3. And then I'm going to rationalize it. I'm going to times top and bottom by √3. So my final answer, my final answer is a √3 over 3. That is my final answer. Okay, on G. So on this one, I'm going to find an arctan. Okay, so arctans go from here to here, remembering that I have an asymptote here and I have an asymptote here. And in this particular case, they want it for 3/4. So I'm not really going to think of this as on the unit circle. I'm going to draw a right triangle where my tangent is positive. I'm just drawing a right triangle. I'm ignoring those dots for a second. Here's my right triangle. This is the angle I'm looking for my tangent to be opposite 3, adjacent 4. Now, this is a right triangle, so using Pythagorean, 3 squared plus 4 squared is equal to 5 squared, which is 25. So this is a 3, 4, 5 right triangle. Now, for that angle, I want the sine for that angle. I want the sine for that angle. So the sine for that angle is going to be my opposite over hypotenuse. This is going to be my opposite. This is going to be my hypotenuse. So my sine is going to be my sine for that angle. My sine for that angle, okay, is going to be opposite over hypotenuse. My answer is 3/4. Now, these ones here, we're going to be graphing. Okay. So on this one here, I'm going to be graphing a cosine. So, when I'm looking at this, my amplitude is going to be 5/2. Let me just get a thinner font here. So my amplitude is going to be 5/2. My vertical shift is going to be -2. My period, because this is x over 4, which is really a 1/4 x. So my period is going to be 2 pi divided by my b being a 1/4. And that's really going to be 2 pi times the reciprocal. So it's going to be 8 pi. And then my phase shift, none. My phase shift, none. So when I'm going to graph this, I am going to have my -2. So I'm just going to draw this. This is going to be -2. I am going to be going 5/2, which is really 2.5, if you want to think about it that way. I'm going to go 2.5 above, which is going to put me at a 0.5. And I'm going to go 2.5 below, which is going to put me at a -4.5. So when I'm doing this, this is my vertical shift. That's where all my like my 0 would be. And then my highs and my lows are going to occur at my 0.5 and my -4.5. Now I'm going to be starting at 0. That's going to be my first mark, my y-axis, second, third, fourth, fifth. And I'm starting at 0. I'm going 8 pi away from that, which is going to put me at 8 pi. This is a positive cosine. So for cosines, I am going to be graphing high to high. So I'm going to be starting here at my 0.5, down to my -2, then to my -4.5, then to my -2, then back up to my 0.5. Cosines are high to high. If it's negative, low to low, and that is my cosine. For number 3, sine. Okay, so my amplitude is going to be the absolute value of a -1/3, which is 1/3. My vertical shift is going to be a 5. My period is going to be 2 pi divided by my b being 8, and that's going to reduce down to a pi force. My phase shift is what makes my parenthesis 0, what makes this 0, and what makes that 0 is a pi force. Now, what's going to happen is I'm going to be starting at pi force. I am going to be going pi force away, and that means I'm going to be ending at 2 pi force, 2 pi force, or pi halves. So my answer to, so my endpoint for this is pi force, pi halves, or you can also think of it as 2 pi force. Okay, so let's draw this. Okay, so I am going to, well, let me just start drawing it. Sorry. Get my my x-axis in. I'll get my y-axis in. So for this, I am going to be starting up at 5. I'm going to be going 1/3 above 5, which is going to be 5 1/3. I'm going to be going 1/3 below 5, which is going to be 4 2/3. And so this right here is going to be my zeros. Okay, that's my vertical shift. My highs are all going to be up at 5 1/3, and my lows are going to be at 4 2/3. And then I'm going to be starting at pi force. I'm going to go 1, 2, 3, 4, 5. I'm going to be ending at 2 pi force or pi halves. Okay. And when I'm doing sine, I start at my 0. And then if it's positive, I go up. But because it's negative, I'm going to go down, back to 0, up to my high, back to 0. And that is my sine graph. For number 4, this is a cotangent and a tangent, okay? So I do have a vertical shift, I do have a phase shift, I do have a period change, I do have an amplitude. What I like to focus on for this, and I'm going to add on here a unit circle for myself just to show us, okay? So let me just make this maybe a little smaller so it doesn't take up the whole space. Okay, so when I'm thinking about tangents and cotangents and secants and cosecants, I know that I have asymptotes. So remember, a cotangent of an angle is your cosine over sine, okay, over sine, but it's also your x over y. So I care about where my y is 0. And my y is 0 here and here. So it's going to be an asymptote normally at 0, normally at pi. A period for tangents and cotangents is pi. So our period will be pi divided by b. Okay. Now, the way I like to think about these is I like to take whatever is my B along with whatever is going to affect my phase shift. Okay, that whole thing there, the 7, whether it's inside the parentheses or outside, I would include. And I'm going to take that and I'm going to set it equal to my asymptotes. So I know that 7x minus pi 6 should have been an asymptote at 0. And 7x minus pi 6 should have been at pi. And then I'm going to see where my 2 new asymptotes are going to be at. So when I'm doing this, I can multiply everything by 6 if I want a fraction bust. Okay, so that's an option we can do. I can times this by 6, and when I do, I'm going to get a 42x. Then the 6's and the next part's going to cancel out, so pi 6 times 0 is 0. So I'm going to get 42x is equal to pi. So x is equal to pi over 42. Okay, for the other one, again, I can times this also by 6. So that's going to be a 42x minus pi is equal to 6 pi. I'm going to add pi. So that's going to become a 7 pi. When I divide, that's going to be 7 pi over 42, or pi 6. We can also think of it as pi 6, but I'm going to just keep it as the 7 pi over 42 for the moment. So now I am going to draw in my x-axis and my y-axis. Let me redraw that better, sorry. Okay, having some issues, sorry. Okay, so in terms of my vertical shift, I'm going to be starting at 1. I'm going to be, because of my amplitude 3, going 3 above that, which is 4. I'm going to be going 3 below that, which is going to put me at a -2. Okay, so those are really going to be my zeros, my highs, my lows, or I should say my ones, my zeros, my -1s. Okay. So that's what it's really going to be. Now I'm going to have some asymptotes. Okay. So I'm going to have asymptote at pi over 42, pi 40 seconds, first, second, third, fourth, fifth. Fifth one was going to be 7 pi over 42. Okay. Now, this is where my asymptotes are going to be. So I am going to be drawing an asymptote through here and an asymptote through here. Okay, those are my asymptotes. And those asymptotes, again, are x equal pi 42. Let me make that smaller. Okay. Okay, so x is equal to pi over 42, and x is equal to 7 pi over 42. So when I'm talking about graphing this, and I'm going around my unit circle, and I'm traveling from here to here, the nice values I'm going to be plotting, this, which is normally, this is pi force, this is where my cotangent is a 1. This is where my cotangent is a 0. This is where my cotangent is a -1. So as I'm traveling around, I'm first going to be plotting my 1. My 1 is up at my high. Then I'm going to be plotting my 0. My 0 is at my 1. Then I'm going to be plotting my -1, which has been shifted here. And then I'm going to connect these points. And there's your cotangent. For number 5, this one is a cosecant. So again, I am going to get a unit circle for myself. Okay, so let me bring a unit circle here. I like to do a lot of things from the unit circle. Okay, it just helps focus me. So when I'm talking about a cosecant, remember, C doesn't go with C, so it's the reciprocal of sine. Okay, so this is going to be so cosecant is equal to 1 over sine, okay, which also means 1 over y. So I want to think about where my y is 0. So this has 0 here and here. So 0 pi. Now, unlike my cotangent, which has a period of pi, I'm not going to stop here. I go 2 pi around. So that's going to bring me back to 2 pi. So I'm going to have 3 asymptotes, one at 0, one at pi, one at 2 pi. So I am going to take, again, what's inside here, including if the 6 had been outside that parenthesis, I would include my b, okay? And I'm going to set it equal to these asymptotes. So my first asymptote, when I take my 6x minus pi force and I set it equal to 0, okay, then I'm also going to have 6x minus pi force, and I'm going to set it equal to pi. And I can do that also for the third one and set equal to 2 pi. but let's get these two done first. So I'm going to multiply everything in this case by 4. That way I just don't have to deal with any fractions. So this is going to be a 24x, then minus pi is equal to 0. Okay, times everything by 4. So that's going to give me 24x is equal to pi. So my first asymptote is going to be at pi 24. So I'm going to plot. Now this one here, I'm also going to times by 4. So I'm going to get a 24x minus pi when I times that by 4 is equal to 4 pi. So I'm going to get a 24x is equal to 5 pi. So I am going to get 5 pi fourths. Now at this point, I can see that I'm adding 4 pi fourths. Oh, sorry, not fourths, sorry, 24. 4 pi 24ths. So I know that my third one, which I could work out, okay, and set equal to 2 pi, but I know looking from here at a pi 24ths to here, which is a 5 pi 24ths, that this one is going to be 4 pi 24ths beyond that, which is a 9 pi 24ths. So that's where that third asymptote is going to be. Okay, so let me again get my graph drawn here. So I am going to draw my graph. Okay, I am going to be starting 3 above. So here, I'm going to maybe drop this down on drop this one down a little bit. Trying to grab this one. Let's drop that down a little bit. Okay, so I am going to be starting up at 3. I'm going to go 4 above that, and 4 above that's going to put me at 7. I'm going to go 4 below that, which is going to put me down at a -1. So again, these are going to be like where my zeros would be. These would be like where my ones. These would be where my -1s would normally be. Okay. Now I'm going to have 1, 2, 3, 4, 5. My first mark, I'm going to write it above since I have that kind of low. This is going to be pi 24. So that's going to be my first asymptote. This is going to be 5 pi 24. That's going to be my second asymptote. This is going to be 9 pi 24, which is going to be my third asymptote. And then I'm going to draw my asymptotes in. So I'm going to have an asymptote here. I'm going to have one here and here. These are my 3 asymptotes. And when I'm doing these 3 asymptotes all have equations. Okay, the equations you can see over there, but let me just write. This one would be x is equal to pi 24. This one is x is equal to 5 pi 24. And this one is x is equal to 9 pi 24. That could be reduced, but I'm just going to leave it so we see that they're all equally spaced. Now, as I'm going around the unit circle, the only nice values I'm going to plot is I'm going to plot this, which is where my cosecant is a 1, and then down here, which is where my cosecant's a -1. So I'm going to go up to where my cosecant would be 1, which is up here at 7. And then I'm going to go down here where my cosecant is would be my -1. It actually is at -1, but I have a vertical shift. And there's our graph. Okay, on this next section, I'm thinking about angles, so I'm kind of thinking the same way as inverses, but I'm not focused on just one positive and one negative quadrant. We're going to be going from -2 pi to 2 pi, okay? So when I'm doing these problems, okay, and we want to give them as radians, when we're doing these problems, I'm going to try to think about where is my cotangent? Where is my cotangent? A negative. So my cotangent is a negative in this quadrant here, and this quadrant here. And I'm trying to figure out where my cotangent is a negative root 3 over 3. Okay. So again, I'm really thinking about if I bring these back over here, let me just think of it as this and this before I flip anything. And in this case, I wouldn't flip it because these are cotangents. So what I'm thinking about is I want where I have basically 1 over root 3. That's what I'm going to want. Okay, so it is a cotangent, and a cotangent is a cosine over sine or a x over y. So when I'm looking over here, what I want to look at is this is going to be a 1/2 comma root 3/2. But when I flip, and this I don't want to flip because I want cotangent. So that would end up giving me a 1 over root 3. This one would give me a root 3/2 comma 1/2. And that would give me a root 3 over 1. I want the first one. That is 60 degrees, but 60 degrees is pi thirds. So I'm going to be here at 2 pi thirds. And I'm going to be here at 5 pi thirds. Now, those are my answers as I go around the unit circle, positive 2 pi. Well, if I go backwards, negative 2 pi, going this direction, this is not going to be a 5 pi thirds. It's going to be a negative pi thirds. And as I continue going to here, this is going to be a negative 4 pi thirds. So those are going to be my 4 answers. My 4 answers are going to be a negative 4 pi thirds, a negative pi thirds, a 2 pi thirds, and a 5 pi thirds. Those are my answers. That's a 3. I don't know what's going on here. Okay. So let's take a look at the next one. Get rid of this. Okay. So now when I am looking at this, let me just take these off. So here when I'm dealing with secant, remember, S doesn't go with S, and I say that so that we know that the reciprocal of secant is not sine, it is cosine. So I'm really trying to think about cosine. Okay, that's what I'm really trying to think about. So I really want, where is my cosine going to be the reciprocal of this, which is a 3 over 2 root 3. I'm going to rationalize this. I'm going to times the bottom by root 3. I'm going to times the top by root 3. When I do, I'm going to get a 3 root 3 over 2 times 3. I apologize. 2 times 3. So it's really a 3 root 3 over 6, or this 3 and 3 can cancel out. So I really want to know, where is my cosine a root 3 over 2? Now my cosine is positive in these 2 quadrants. That's where my cosine is positive. So instead of thinking about the angle that gives me a secant equal to 2 root 3, I'm going to think of the angle, which is the same angle, that gives me a cosine equal to a root 3 halves. And that is going to be here at pi 6 and here at 11 pi 6 as I go from 0 to 2 pi. But as I go backwards this direction, this is going to become a negative pi 6. And as I continue going around, all the way around to here, this is going to become a negative 11 pi 6. Now you see how these ended up being opposite signs of the original ones? That's not always the case. That was not the case over here. So don't assume it is. Pay attention to how you're moving around the unit circle. So our answers are basically going to be a negative 11 pi 6, a negative pi 6, a positive pi 6, a positive 11 pi 6. Those are our answers. Now, the next one, where is sine equal to a negative 1/2? So my sine is going to be negative in these two quadrants. Let me try again. It's going to be negative in these two quadrants. And so I'm looking to see where my sine is a negative 1/2. That's going to be here, and that's going to be here. This is going to be 7 pi 6. This is going to be 11 pi 6. That's going from 0 to 2 pi. Going backwards, this direction, this is going to end up being a negative pi 6. Continuing over to here, this is going to end up being a negative 5 pi 6. So my four answers are going to be a negative 5 pi 6, a negative pi 6, a 7 pi 6, and an 11 pi 6. On 7, we're going to write an equation of a cosine function with an amplitude of 6/5, a period of 7 pi tenths, and a phase shift of pi thirds, and a vertical shift of 9/4. So when we're talking about a cosine, we have A, which is our amplitude, cosine of B, which is the number of cycles within 2 pi distance for a cosine or sine graph, times x minus h, which is going to be your phase shift, plus k, which is your vertical shift. So in this case, our amplitude is 6/5. So we're going to have y is equal to 6/5 cosine. Now for my b, we have two ways to think about your b. So I'm just going to draw it over here. B is equal to, well, let me start this way. We know that our period is equal to 2 pi divided by b. We also can rewrite that as b is equal to 2 pi divided by our period. I think I'm going to use this first one because I don't want to put a fraction in the denominator. I can do it, but I think I'm just going to use this one. So what I'm going to do is I'm going to take 7 pi tenths and set it equal to 2 pi over b. I'm going to cross multiply, so I get a 7 pi times b is equal to 20 pi. I am going to divide by 7 pi, and when I do, that's going to give me a 20 over 7. So I'm going to get 20 over 7 as my b. They told us we had a phase shift of 1/3 of pi thirds, which means I'm going to go x minus pi thirds. And then we had a vertical shift of 9/4, so that's going to be plus 9/4. That's our equation. On these ones down here, we like them written in kind of the format that I wrote the one above. These ones aren't all like that. So the first thing I notice is we have a 6 here. So I'm going to times everything by 6. So I'm going to go 6 times this, 6 times this, 6 times this. So I'm going to get y minus 42 is equal to 12 cotangent 3x plus pi halves. Then the next thing I'm going to do is I'm going to rewrite it with y by itself. So I'm going to go y is equal to 12 cotangent 3x plus pi halves plus 42. Now my amplitude is going to be 12. My period for a tangent and a cotangent is pi divided by your b. Phase shift is going to be negative pi halves, and my vertical shift is 42. For my next one, again, I'm going to rewrite it. So first thing I'm going to do is let's take the 8 to the other side. So I'm going to have 12 sine 3x plus pi over 6 minus 8. The next thing I'm going to do is I'm going to divide everything by a -2. I'm going to divide by a -2. I'm going to divide this whole thing by a -2, and I'm going to divide this by a -2. So I'm going to get y is equal to a -6 sine, let me move it over slightly, of 3x plus pi 6. And then I'm going to get a plus 4 when I do that math. So my amplitude is going to be the absolute value of a -6, which is 6. My period for everything but sines, I mean, tangents and cotangents is always 2 pi divided by my b, so 2 pi thirds. My phase shift, I'm going to actually take, I'll do it in orange, 3x plus pi 6. I set it equal to 0 and work it out. So I'm going to be subtracting pi 6, which is going to be a negative pi 6. I'm going to divide by 3. And when I do that math, I'm going to get a negative pi over 18. And then my vertical shift is 4. Okay, last part here. For this page is going to be where I am talking about domain and ranges for each of these. So again, for these, a lot of times I like to use the unit circle. So I like to use a unit circle just to kind of focus myself each time I'm doing these problems. So when I'm talking about sine inverse, remember sine is positive, positive, negative, negative. So remembering that for inverses, I am going to go from here to here. And when I say that, this down here is a negative pi halves. This up here is a positive pi halves. Okay. Now, my domain for this is going to be from -1 to 1 because my normal sine graph, my maximum is a 1, my minimum is a -1. And as I'm graphing this, my sine looks like this. So the highest and lowest it goes is 1 and -1. That becomes my new domain. My range and my domain are switched. So the maximum and minimum for my domain is going to be -1 to 1. Close brackets because it includes -1 and includes 1. My range is going to be the radians that I showed over there. So it's going to be negative pi halves less than or equal to y less than or equal to pi halves. Okay. Or the way I generally write it is negative pi halves to pi halves. Now this one, if you want to write it in inequality form, this is what it would be in inequality form. -1 less than or equal to x less than or equal to 1. And then we want to sketch a graph of this, okay? So when I'm sketching a graph of this, I am going to be going to 1 and -1. I'm going to be going up to pi halves and negative pi halves, okay? So I've got 1, 2, 3, 4, 5, kind of how we're going. So when I am doing this, what we want to pay attention to is what here is where my sine is a -1 down here. So what angle gave me a sine? I don't know why I put negative on that side. I'm sorry. -1, +1. What angle gave me a sine of a -1? A negative pi half, so I'm going to be down here. What angle gave me a sine of 0? 0. What angle gave me a sine of 1? Pi halves. And these are endpoints. That's your graph. That's it. Now, cosecant, C doesn't go with C, so this is really my sine. Okay, so this is 1 over sine X. Okay, which is really 1 over Y. So I'm thinking about where my Y's are zeros. My Y's are zeros here, here, and back. So 0, pi, 2 pi is where I'm going to have asymptotes. So for my domain, it's going to be all real numbers except, and I'm going to write it as 0, and I'm going to keep adding or subtracting pi over and over again to get from 0, pi, 2 pi, 3 pi, and so forth. So pi k. And then my range for these, remember, it's going to be 1 up here. It's going to be -1 down here. And this is going to be where it's going to go from 1 up and 1 down. So that's going to be -infinity to -1 close bracket union 1 to infinity. Okay, or y is less than or equal to -1. That's a -1. Or y is greater than or equal to 1. You can think of it both ways. Now, when I'm graphing this, I am going to, let's see, get rid of that. Okay, so when I'm graphing this, I am going to be starting here where x is equal to 0. That's going to be 1, 2, 3, 4, 5. So here at 0, okay, all the way to 2 pi, I'm going to have asymptotes. I'm going to draw them in a highlight. Okay, so this is going to be 1 asymptote. This here at pi is going to be an asymptote. This here at 2 pi is going to be an asymptote. So I have at x equals 0, at x equal pi, at x equal 2 pi. And then I am going to be going from 1 and -1 up or down. So you see, as I'm traveling here, I'm going to first be at 1, and this is going to go up. And then over here, I'm going to be at -1, and it's going to go down. Now here, we're going to write 1 sine and 1 cosine graph. Now, what I like to do is I like to think about where my high, low, and middle will be. So my high, it looks like, is up at 1. My low, it looks like, is at -3. So let me just kind of write these so we can see this. This is at a height of 1. This is at a height of -3. So halfway in between that, if I add them, 1 and -3 give me a -2. -2 divided by 2 is a -1. So my zeros, my vertical shift is going to be here. That's where my vertical shift is, at -1. Okay. So from here, I can find my amplitude. My amplitude from here to here is 2. My K is going to be -1. Now, depending on where I'm starting, I might have a different equation than somebody else. Now, what I notice is if I start here, okay, and I go all the way to here, that is 1 cosine. And the period of that cosine is 2 pi thirds. So my period for both of them is the same. They're both going to be 2 pi thirds, but it was easiest to find it using my cosine. Now, if my period is 2 pi thirds, remember B is equal to 2 pi divided by period, or your period is equal to 2 pi divided by B. So I think I'm going to use the second one because I am going to put in place of my period 2 pi thirds, and I'm going to set that equal to 2 pi B, and hopefully you guys can see that in this case, my B has to be 3. I didn't really have to do much math on that. So that's my B. Now, my phase shift depends on where I'm going to start. So myself personally, for a sine, let's say you want to start at a 0. So let's say I start here, and I'm going to go from here to here. The period is the same as it was for my cosine. So this is going to be y is equal to my amplitude. I'm doing a positive sign, so 2 sine. My b is 3. I am starting at, if that's a negative pi thirds, this is going to be half of that, which is going to be a negative pi 6. Okay, because if I take pi thirds and divide it by 2, I get a pi 6. So this is going to be x plus pi 6, and then my k minus 1. Now for my cosine, I'm going to use the orange cosine I started. So I'm going to go y is equal to 2 because it's a positive cosine, high to high. Cosine, my period is the same. This time I'm starting at 0, so that's just plain old x minus 1. So on problem 11, we have a bike tire that Johnny's driving his bike when a tack becomes stuck in his tire. Okay, so he's driving and then there's a tack here and then it's going around the bike. Okay, tire. Now in this situation, the tire has a radius of 32. So if I'm starting here at the center and I'm going to the bottom, that's going to be 32. And then if I'm going to the top, that's also 32. So in this situation, it's a little different than a lot of the ones we see. Our high is going to be up here at 64. Our low is going to be 0. Okay, a lot of times we aren't starting at 0 in terms of our low. And then our center or our vertical shift is going to be at 32 in this case, okay, at 32. So in terms of my graph over here, I am going to have 0, 32, 64. And again, my 64 and my 0 are going to be my high and low, and my 32 is going to be my vertical shift. So even without me drawing anything, I see that my amplitude is going to be 32 because that's the distance from here to here and from here to here. It's not always the same as our vertical shift, but because our circle is sitting on the x-axis on the ground, it is. Okay, so then in this, it says it makes 1 complete revolution every 500 milliseconds. Okay, now when you look at the rest of the problems, they talk about things in seconds. So I want this in seconds, not in milliseconds. So I want this in seconds. So if it takes 1 revolution for 500 milliseconds, so it's 1 revolution equals 500 milliseconds. And it says 1 second is 1,000 milliseconds. That means that it took half of a second. Okay, half of a second. Or 1/2. So I am going to go 1, 2, 3, 4, 5. This is going to be 1/2, or you can also think of it as 0.5, whichever way you want to think about it. Okay. Now I'm going to be plotting the tire with the tack starting at 0. Then it moved up to 32. Then it moved up to 64. Then it's coming back down to 32. Then it's coming back down to the ground. And I'm going to think of this as a cosine graph. And I know my vertical shift is going to be 32. Again, your amplitude and your vertical shift aren't always the same. This particular case it is. I also am going to have my 0 be my start, so I don't have a phase shift. And my period is going to be equal to 1/2, half of a second. And so when I'm trying to find my B, let me do it over here. B is equal to 2 pi divided by my period. So it's going to be 2 pi divided by 1/2. So I'm going to multiply by the reciprocal. I'm going to get 4 pi. So my B is going to be 4 pi. So when I go to write my equation, the equation is going to be y is equal to, it's a negative cosine, so it's a negative 32 cosine. My B is 4 pi times x, okay, because I'm not going to have a phase shift, plus 32. That's going to be our equation. Now I'm going to try to figure out how high will the tack be when the group, when I don't think that's supposed to be the word group there, when it's 32.38 seconds after being lodged into the tire above the ground. I think that's supposed to be ground. Sorry, above the ground. After the becoming lodged into his tire. Okay, so in this case, I'm basically going to go negative 32 cosine of 4 pi times 12.38 seconds plus 32. Okay, and I'm going to get that answer. So let me just get Desmos over here. And Desmos automatically is in radians. Okay, so I'm just clicking on the wrench here. And so I'm going to go negative 32 cosine, and I'm going to go parenthesis 4 pi times 8, close my parenthesis, plus 32. And sorry, it wasn't 8. It was I don't know why I put 8. 12.38. I apologize. And that's going to be 29.99. Okay, for that answer. Okay. So that is going to be 29.99, 29.99 seconds. So about 30 seconds. I mean, not seconds, sorry. Centimeters. Okay, this is centimeters. I should have labeled this. This is centimeters here. Centimeters on the y-axis. So that's going to be centimeters. Now, the next question asks, find the first time after the tack is lodged in that the tack is 40 centimeters above the ground. So I'm basically going to go 40 is equal to negative 32 cosine 4 pi times x plus 32. I'm going to put this into Desmos or into my graphing calculator. Okay. Now, I have, let me just make this bigger. So we want to know 40. Okay, when it's at 40. So hold on. Let me come here. Okay. So I'm going to go y equal, and I'm going to put x here instead. So I'm going to get this. Now, this is going kind of crazy because every half a second, it has a revolution. So I'm going to come here and let's just kind of change this. Let's say we go from 0 to, let's say, 1 just to kind of see what's happening. And it needs to go from 0 to 64. Okay, so you see within 1 second, I've had 2 revolutions. Okay, and I want to know when it's at a height of 40. So I'm going to draw in y equal 40. Okay, and then I'm going to come here, and that's going to be at 0.1451 seconds. Okay, 0.1451 seconds. I'm going to kind of take a screenshot of this. I'm going to add that on to my paper. Okay, so we wanted to figure out when it was 40 feet above the ground the first time. So 40 feet above the ground the first time was 0.1451 seconds. Okay. Now find the next time when the tack is 40 feet above. So the next time is going to be here. Now, to work that out, I can again go back to this. Let me get my graph back. Okay, here you see it's going to be a 0.359. Okay, so that would have been a better picture to put, honestly. Okay, so let's get this one. Okay. And come back here. I'm going to take this one, get rid of that one. And let's put this one. Okay. Oops, don't want to do that. I want to grab this. Okay. So now we see that one answer is 0.1451 for the first time. The second time it was at 0.3549 seconds. That was the second time. And that's the end of this video.